sampler 2D screen space sampler glow hors for horizontal equals sampler underscore state, open curly brace here, texture equals greater than symbol screen space glow hors close greater than sign semicolon, and we have mag filter equals linear semicolon, min filter equals linear semicolon, mip filter equals point semicolon, wrap s equals clamp to edge semicolon, wrap t equals clamp to edge semicolon, close curly brace semicolon. Alright, so that gets us set up for doing our horizontal calculation and our vertical, or at least our vertical should be here. No, we just have horizontal. Oh, sorry, doing vertical next. I was like, we should have vertical too. Okay, so copy and paste your horizontal to do the vertical one. So copy and paste that. It's all the same exactly. Only thing is you're going to change hors here to vert. So change that to vert in both places. So here, change it from hors to vert, from hors to vert, from hors to vert. Otherwise, it's all the same. Oh, yeah, and give it a name of 2 here instead of 1. So change that to screen space glow 2 here, because we're doing it for vertical. If you want to, you could say vert in here instead of 2 and say hors here instead of 1, and that'd be fine. For instance, I could say horizontal. And then this one be vertical. Alright. Alright. And then that just makes it a little easier to track them as to what one's what. Now when I bring the cursor over here, I can easily see which texture is what. So if I come in here like so, and I do that, this is the horizontal one, and this is the vertical one. So very cool. Makes life a little easier to follow all this, and that's what's going on with that. Yeah, that's kind of cool. Horizontal, vertical. Awesome. Alright. So anyways, with that, moving on along, and we still need to do our depth buffer texture. Now you should have this from your radial blur shader. But if not, if you're just doing it from scratch, here we go. Texture, depth buffer, texture, colon, render depth stencil target. And then we say open greater than symbol, float 2, viewport ratio equals, close curly brace, 1.0, comma, 1.0, close curly brace, semicolon, string format equals, in quotes, D24, S8, close quotes, semicolon, string UI name equals, in quotes, depth space buffer space texture close quotes semicolon, string space UI widget equals, in quotes, close quotes, semicolon, close greater than symbol, semicolon. Alright. And that is the render depth stencil target right here, or basically our depth buffer texture. Okay, going on down here. Alrighty then, we need a few things to have in place for doing this. Alright. So first we're going to do our struct vsn here, float 3, position, colon, position, semicolon, float 2, uv, colon, text coord 0, semicolon, close curly brace, semicolon. This should be for our screen space line quad, if I'm not mistaken. Okay, now we need to do our actual glow processing here. So this is going to be for processing our coordinates for each of those pixels, with all the different sampling that's weighted so that we can blur them together and make it glow. Okay, so to do that, open curly brace here, float 4 here, position, colon, position, semicolon, float 2, UV, colon, text coord 0, semicolon, float 4 here, UV, wait a minute, is that right? Did I make a mistake? I might have made a mistake. Hold on a second. I don't think those are supposed to be... float 4s. Hold on a second. I don't like that. I don't think that's supposed to be a float 4. I think it's supposed to be float 2s. That makes sense to me at the moment. Unless I'm just not remembering something correctly, but I doubt that's the case. Alright. I save you and I say compile. Are we going to break everything? Yes, we are. Okay. Nope, they are 4s. I'm mistaken. I'm not remembering correctly. Alright. That is not a mistake. Those are float 4s. And it's because we're running the calculations and passing them back through images, and then we're handling the calculations later on on a deferred type method, and I'm not thinking. My apologies. Here we're handling it in parallel for doing these together, which is efficient by streaming the data across. Oh, sorry. So, anyways, float 4 here, UVW. This makes it a 3D UV. So text chord 1, semicolon. Float 4 UV2, colon, text chord 2, semicolon. Float 4 UV3, colon, text chord 3, semicolon. Float 4 here, UV4, colon, text chord 4, semicolon. And yeah, X, Y, and Z, W used as UV coordinates. Yeah. The thing about this is a multi-streaming, multi-threaded method, and it's the reason why we're doing this, so that way we can get parallel processing at its utmost, and we make more use of the 3D cards in their streaming capabilities to simultaneously handle and process multiple things at once. And doing this, it allows us to have higher speeds for calculations and makes the whole process run faster. I wasn't thinking a second ago, so that's what the deal is with that. I just couldn't remember. I wrote this quite a while ago, so things are not as... I can't remember things as well from when I wrote it from now, basically, as far as that goes. Anyways, curly brace here, semicolon. Alright, so here we're going for our vertex shader to our pixel shader, as it says. And here it is, VS out. So here is our position, colon, position, semicolon, float 4 here. And then float to UV, colon, text chord 0, semicolon. Close curly brace, semicolon, struct, FS out. Open curly brace here, float 4, color, colon, color, semicolon, close curly brace, semicolon. And then let's look at our vertex shader. Alright, so our vertex shader for our screen space align quad is VS out, main VS here, open parentheses, VS in, space, IN caps, close parentheses, open curly brace here, VS out, space out, semicolon, out dot position equals float 4, open parentheses, in dot position dot xyz comma 1, close parentheses, semicolon, out dot uv equals in dot uv dot xy, semicolon here, and then we return out, semicolon, close curly brace here. Alright. Vertex shader to align blur samples vertically. So here's one for aligning it vertically. So 9 textile vertex here, and we have vert 9 here, blur VS, open parentheses, VS, IN, space, IN in caps, close parentheses, open curly brace here, 9 textile vertex out, semicolon, and then we have out dot position equals float 4 here, close parentheses, open parentheses, IN dot position comma 1, close parentheses, semicolon. And then we have float here, textile increment equals glow span divided by viewport size dot y, close semicolon here. So again, this gives us our position here. Now we're doing our increment here. So viewport size here divided by glow span. So again, glow span lets us decide just how far out on the textiles with the go. And if we go too far, if you remember that, then it starts getting pretty choppy. So that's where that's coming from. So that way we control how far out it spans for doing the pixel lookup and just how far that goes. And we have control of that as an artist-driven control. It's really cool. So this dynamically scales the number of pixels we sample across and how far we sample out from the main center point there. Alright. Or the main center point in this case, of course, is the pixel that we originally sampled, or the pixel we're modifying. Or if you want to look at it another way, the fragment we are modifying, since it's an uncomputed pixel. Anyways, float2 here, space chord equals float2 here, open parentheses, in.uv.xy, close parentheses, semicolon here. So we're setting up our coordinates. And then out.uv equals chord, semicolon, and we have out.uv1 equals float4, open parentheses, chord x here, comma, chord y dot plus textile increment, comma, chord x here, space, comma, sorry, chord dot y minus textile increment, semicolon. So let's just pack it together. If you go back and look at your algorithm here, check it out. You will get to see a pattern. We can we'll just swap this around for order. It doesn't matter, but this is what we've done for the order, so that's what we'll stick with. Essentially, we've moved where? Vertically. Check it out. We've moved off into one place here vertically, and then we've moved, so let's just move up since we subtracted for that one, and then this lets you move down for the adding. And it's the same algorithm right here as what we're doing in the code. And then that's what this whole line is essentially. So here we have our original x position, right? And then we're taking our y position for that UV there. And we are adding the textile, or shall we say we're going down in our texture. And then in the next one we're doing our x again, because we're staying in the same place horizontally, okay? And then we're going to say, alright, now let's go vertically up one. Or it doesn't necessarily have to be up one, it could be up multiple. It's just based on wherever the textile increment is. And that's based again off of the glow span divided by the viewport size. So that makes sense. And then that defines just how much we increment, or how far over we move one way or the other, essentially, inside the pixels. If this is just 1.0 here, this will move over 1 pixel, or textile if you want to look at it that way. If, however, we want to move a couple pixels over, if this glow span is 2 or whatnot here, if the textile increment here is 2 overall, this will move over 2 pixels instead of 1, etc., etc., etc. Alright, going even further with this. Alright, so this lets move over, assuming that textile increment is 1, over 1 pixel. Sorry, when I say over 1, I mean like up 1 or down 1. That's a better way of saying it, since we're not going horizontally here. Since we're going vertically, when I'm saying over 1 or whatever, I basically mean over 1 from above or below. So that's going to be vertically or horizontally. No, it's not vertical, sorry. Vertically, either up or down, for we're moving up and down along the same one. So let me illustrate that a little better, what I was trying to say here. Essentially, this is where we're at. And subtracting is letting us do this, go up. And if this is textile, if that textile increment is 1, that'd be 1 textile up, we would go up 1. If it's textile increment is 1 again, and we add, let's go down 1 to there. And like magic, ta-da, there it is. Now on the out.uv2 here, we got something else that's happening. And essentially what that is, basically, is that we are now going 2 textiles over by a factor of 2. So it's the exact same algorithm as before. So you literally can take this and you can just copy and paste it, and then add times 2, then times 3, times 4, times 2 again over here, times 3 over here, and then times 4 over here. What is this doing? Well, let's give you the mathematical example again here. So for instance, let's just do the let's just talk about out.uv2 here, and let's focus on this times 2 here for our textile increment for adding it to our y. Now remember, y is going to be vertical here, right? So what does that mean? So for adding a y, right, it's going to take us down because 1's down here. So it's going to take us down. So if textile increment was 2, was 1 in here, and we multiplied textile increment times 2, we'd end up with 2, which means 2 textiles. So we go down 1, then 2. And that would place us here at this textile. Now when we're subtracting it, when we say our textile increment times 2, remember our textile increment was 1, if it was 1 anyways, then when we multiply that times 2, it's going to take us up 2 pixels and sample from there. Awesome. Same thing here, but for UV3 it's going to be times 3. So which way we're going to go? Well, basically where we're going to go is we'll go as soon as I click on the right thing. So times 3. Let's say the textile increment was 1, right? Now it's going to go, and you add it. It's going to go 1, 2, 3 pixels down, textiles down, if you will. Either way you want to say it. And then again, if we're subtracting, it'll go up, so it's going to be textile increment 1 times 3 gives us 3 textiles upwards, so that should be 1, 2, 3. And then we get to UV4, check it out, it is multiplied times 4. Obviously, you probably get the pattern by now. So if you add textile increment times, which would be 1 times 4, that makes it 4. So that'd be down 4 pixels, textiles, if you however you want to say it. So 1, 2, 3, 4. And then if you subtract it, it'd be 1, 2, 3, 4 going up. And so that lets you access it. Now again, depending on the textile increment, it's going to adjust all these dynamically based on multiplications proportionally. So it'll make it jump out so much further, or so much less further, so on and so forth, as far as that goes. So this is a really nice dynamic algorithm where you can easily manipulate it and thus gain additional spread on there for your sampling, or reduce your sampling dynamically on the fly as a user-driven control. So this is wonderful because this makes this algorithm basically allow it to be modified and expanded and easily tweaked on a per situation basis by the artist. So that's ideal, and that works great. Exact same algorithm here, so copy and paste this down below, and then change our vert here to hors for horizontal, and it'd be 9 blur, or so hors 9 blur vs, etc. So let's change the vert to hors, and then we're going to say under we're going to change the algorithm. So before we did it on Y, now we're going to move that textile increment over here to plus on the X. So remember, we're manipulating vertical, so we're saying chord Y plus textile increment, and now we're manipulating horizontal, so it's got to be chord.x plus textile increment chord Y comma chord dot Y comma, because we're not going to manipulate Y, we want to stay in the same place the whole time here, so no manipulation there, and then we just want to move horizontally only, and then chord X minus textile increment here comma chord Y dot Y comma close parentheses semicolon here, out.uv equals float for chord plus chord X plus textile increment times 2 comma chord Y dot Y comma chord dot X minus textile increment times 2 comma chord Y dot Y close parentheses semicolon. Of course, the only thing we do is take this first line, copy and paste it, and change our textile increments to textile increment times 2. So just add a times 2 here to each one of these. And then on the UVs, same idea, times 3, times 3. And then again on UV4, times 4, times 4. And again, this works. Why? Because if we go look at the math, well, yeah, check it out. Here's our horizontal step. It's a total match for our algorithm, and we are now moving horizontally. But of course, this is on X and not on Y. And then to top it off, wrong one. This lets us move horizontally or whatnot. So we add it, we move over 1 for our pixels. However, if we do our pixel increment times 2, we're going to move over 2 pixels to the right, or if we subtract it, 2 pixels to the left of that pixel. And then you multiply it times 3, and it'll be 1, 2, 3 pixels to the right when you add it, and then you multiply it times 3 for the pixel increment, assuming the pixel increment is equal to 1, of course. And you subtract it, you're going to go to the left 3 pixels. And then times 4 again for the pixel increment, and it's going to go added, it's going to go over 4, and then subtract, it's going to go over 3. Over 4 to the left. So that's going to let you go between all those pixels there. And again, this scales dynamically based on the user input here. And that's all driven dynamically also. Alright. Going further. So now we need to do our FS out here, and it's going to be blur 9 PS here, open parentheses here, textile 9 textile vertex in, comma uniform sampler 2D screen sampler, close parentheses, open curly brace here, FS out, semicolon. Out.color equals text 2D, open parentheses, screen sampler, comma, in.uv4.zw, close parentheses, times kw underscore 4, semicolon. So this weights it. So don't forget our out.color is our final color. And these have already been pre-weighted. We did that up before. We don't have to do our divide because we pre-handled our division by setting everything, scaling it proportionally perfectly ahead of time, so we don't have to worry about the divide at the end here. And this is just going to let us combine all these. So we're combining all these different passes as we did our dual processing on these different parts here. So that's pretty cool. So out.color here, plus equals text 2D here, open parentheses screen sampler, comma, in.uv3.zw here, close parentheses, times kw underscore 3, close semicolon. So basically, if you take this first line here, copy and paste it, add a plus here, and then change that 4 to a 3, and then this 4 to a 3 here, you have this whole line. Then copy and paste it over and over again, and change the 3 to a 2, and a 2 to a 2, because again we're just weighting them for each one. Then change that 3 to a 1 here, at this one right here, and change that 3 to a 1 here. Semicolon. And then just take away the 3 altogether on these two, and change that to a 0. And then keep pasting. So you're going to paste one more here. And on this one, you're going to change your ZW to XY, because we need to now allow for this one also. Because remember, we did this as 2 different parts here on our float 4. As 2 sets of coordinates. So we had our U and V, and then we had our Z here. Or our W and our Z, shall we say. Yeah, our ZW here. So there's our ZW, and here's our UV right here. That's our V, and here's our U. Alright. So here we are, out.color plus equals text 2D here. Well, you don't have to type all that, you just copy and paste it from a second ago. So yeah, change that to XY instead of ZW. And then this is going to be a 1 here for your KW weighting. Alright, awesome. So now select this whole line here and copy and paste it over and over again 3 more times, and change that 1 to a 2 on each one of these here. Okay, so this combines our different values here as an averaged setup, and they're all properly weighted now, and then so we get our final color result. So we just do a return out. So now we need to add glow. So this is our final result of our blur. So this blurs it. Doesn't make it glow, it just gives us a perfect blurring. So this is actually a way, if you wanted to do a way of blurring the screen or something like that, this method would work for doing that. So we can use this as a blur filter too. But in order to make it glow, glow is a blur plus brightening. That's all it is. It's very simple. So all the hard work is the actual blur itself, and then the glow itself is actually quite simple. So we're going to take our blur and we're going to use it with our glow. Alright. So we're going to do that right here. So our glow PS here, VS out here, IN, take that in. FS out is what we're passing back out. So FS out, out here, semicolon here, float force, SCM for our screen here equals sceenness times text2d screen space sampler in.uv, which would be the result of this right here. Remember, went out to our screen space sampler, so we have that handled there. And then float 3 here, glow equals glowness times text2d here, open parentheses, screen space sampler, glowvert here, comma, and then in.uv.xyz semicolon. Alright, and we're multiplying that times our glowness in the vertical. Alright. Awesome. So now we're controlling the brightness of the glow. Okay. And now we're saying out.color equals float 4 here. And we're just doing our scene plus our glow value. And then we're doing our scene.w here. So very, very cool. And this allows us to brighten it up quite a bit. So this gives us RGB here and then alpha. Okay. And return out, close curly brace. And now we just get down to our techniques. So this allows us to combine these. Very cool. Very cool indeed. Make sure I didn't miss anything. I don't think I missed anything explaining anything. Alright. Okay. How does this work? Well, it all breaks down to the technique, of course. It's all in the technique. So technique here, space technique 0. Right here. For define it, open less than sign string script equals, and in quotes, render color target 0 equals screen space texture semicolon close quotes, open close render depth stencil target equals depth buffer texture close semicolon close quotes, open parenthesis open quotes here, clear set color equals clear color semicolon close quotes, clear set depth equals clear depth semicolon close quotes here, clear equals color semicolon close quotes, clear in quotes here, clear equals depth semicolon close quotes. Alright, and that gives us all our colors set up for setting all that up for our color and our depth and clearing it out and all that fun stuff. So we set the color beforehand before anything is drawn, and then also we have our render depth stencil target here equals render sorry, depth buffer texture or screen space texture here semicolon for handling those. Alright. Alright, so inside of this technique we have 3 passes, right? So the first pass we have to compute is horizontal. Second pass we have to compute is vertical, and the last pass we have to compute is going to be glow. Now you may remember we only bothered to handle glowiness and vert, and this will be explained in the technique here in a second. Alright, so pass blur glow buffer underscore horizontal. We're going to process this one first. Alright, so render color target 0 here equals screen space glow horizontal, semicolon, end quotes here. Render depth stencil target here equals depth buffer texture, semicolon, close quotes. Draw equals buffer, semicolon, close quotes, semicolon. Close greater than symbol, open curly brace here. Depth test enable equals false. And then we have our depth mask would equal false too. Cold face equals false. Blend enable equals false if you needed it. Depth func equals L equal, semicolon. Of course we don't need that because we already have our depth test set to false. Vertex program equals compile here, space VP40, space horiz 9 blur VS, open close parentheses, semicolon. Fragment program equals compile space FP40, space blur 9 PS, open parentheses, screen space sampler, close parentheses, semicolon, close curly brace. Oh, I just gotta see how far can we take this one. Probably pretty far, because I don't think there was anything but basic mathematics, so we should be able to go really low with these. Only question is, can it handle the, yeah, I was about to say, only question is, can it handle the card throughput of the actual, the answer is no, it can't, below VP30 and FP30. The card has to be able to have enough streaming capability to handle this, because remember, we computed multiples of these simultaneously, so in those 3D textures, so it's important that it can handle the streaming capabilities. Alright, pass blur glow buffer here underscore vert, open lesson sign string script here, render target equals screen space glow vert, semicolon, close quotes. Render depth stencil target equals depth buffer texture, semicolon, close quote, quotes here. Draw equals buffer, semicolon, close quotes, semicolon. Alright. So in our glow horizontal, we passed in the screen space sampler, right? Well, the value we pass in, instead of being the screen space sampler, into our vertical one is the actual horizontal one. So it already has the horizontal blur in there, and then you're vertically blurring it the other way. So this gives you the full blur. This is only blur in one direction. This is blur in both directions because we take the horizontal blur and then we blur it vertically too, thus giving us a full blur both vertical and horizontally. So that's what's going on as a two-pass step. So this is a multi-pass setup. You are doing this in 2 passes, and that's how we're handling it all in one go. All right. Very cool. Alrighty then. So let's look at handling this here and now. Okay. So all you have to do here again is depth test enable equals false, semicolon, cold face enable equals false, semicolon, vertex program equals compile VP40 vert 9 blur VS. So again, we could probably get away with 30 here. So we're just calling our vertical blur. And then when we get to our blur on the PS one, we're now passing in the horizontal sampled screen space instead of the actual screen space sampler from the original render. So realize the original one here for our blur glow buffer pass here, we're using our good old blur 9 PS. If you need to remember which one that is, that'd be this one here, where we're averaging them together. Okay, so we average it all together for our results from our horizontal pass here. So we're going to pass in, though, the actual render target, which is this one right here, for screen space. Now this is the original one before we start modifying it. And that's what goes right here. So we're passing this in here, and we have our horizontal blur done on the vertex here, and then we're actually computing it on the screen space image here, and we're getting our results accordingly. Now, when we get over here, we do our vertical blur for our VS, and then we do our blur here on our screen space sampler glow horizontal instead, but using the same exact function again. So now we average it yet again, and thus weight it for our vertical based on our horizontal blurring that we did earlier in the above pass, which of course is blur, glow, buffer, horizontal here, invert here for vertical. Alright, so that lets us blur it horizontally and then vertically. And so of course we're vertically blurring the horizontal, so thus we have it blurred in both directions, and this is our final blurring. Great. So then we need to do our glow pass in order to brighten things up. So that's what we need to do here, and this is our final step. So glow pass, here open lesson symbol, string script equals, in quotes here, render color target 0 equals nothing, semicolon, close quotes. Open quotes here, render depth stencil target equals nothing, semicolon, close quotes. Open quotes, draw equals buffer, semicolon, close quotes, semicolon. Open greater than symbol, curly brace here, depth test enable equals false, depth mask equals false, cull face enable equals false, blend enable equals false. Or here, if you did have a depth func, it'd be equal to L equal, but it doesn't matter, don't need it. And then vertex program compile VP40 main VS, and fragment program compile FP40 glow PS. And then in this, it actually calls the glow function here, and we do our final brightening of our vertical screen space sampler here based on with our regular screen space sampler, and we do our mathematics for making it brighter. So we take the original scene and then we add the glow value to it in order to brighten it up. And of course we have full control over that with our options here as to how much of a multiplier that actually makes on the glowness. Remember, we're adding it, so therefore anything above 0 is going to be brighter. So, and that's what we have here. Alright, and that gives us our glow pass, and we're done. Now I'm just going to do a real quick test here. We do a 30 on these. Really don't care if it goes below 30, quite frankly, because we can't compute below 30 here, so it's really, you know, pointless to even go below that. So 30 is required up above. That's as low as we can go. That's just it. Yeah. So there we go. No shocker there. Yet again, compile, and so yeah, VP30 and FP30 as low as we can go on this. Alright, and with that should finish it up, and now you can actually glow. You can expand the range at which you do your textiles manipulation and sampling for your averaging of your pixels based on weighted average based on distance from the original pixel, so that way your original pixel has a stronger influence over the final color and the look of it, and in doing so you can cause this thing to blur better and faster, and you should get a glow, and of course you get this brightening too, and you just come in here afterwards, save and compile, and you should be able to brighten it up like so. You'll notice it's actually lightening up everything, that glow, and you can do some pretty nice intensities with this. Oh, I don't know, something like that. Here I'm brightening up the entire scene instead. Cool. And again, here's our step size. So I'm doing, as I said in my example, this would be 1 textile or pixel out, and it goes out as much as 4 pixels. However, I wanted to, what I had it on a second go was 4 of them. You notice you get this more of a glow hazy effect. We can go as many as 8 pixels out for each sampling. That means that essentially, let me just point this out real quick. That means when we're in here and we were doing this calculation for our textile increment, say, okay, so let's talk about horizontal here. Along the X, this textile increment is based on here. This would be 9 pixels over. I'm sorry, 8 pixels over to the right of this pixel here. And then the next increment would be 16 pixels over. And then the next one would be 8 times 3, I believe it's 24 over. And then 4 times 8 is going to be, should be 32. Yeah. 32 pixels over to the right. So, you know, makes sense here as far as that goes. And of course, you go 32 pixels over to the left. So that's as far out as we allow it to go for our sampling. That's quite far, actually. And you can see kind of what results that gives you. But this allows you to have adjustments over it. And this is a really nice algorithm. It's awesome. Because again, it lets you to dynamically adjust this. You don't have to jump back and code back and forth until you get the right result. And you don't have to worry about having to code out a separate shader on a per case basis. Instead, you can come in here and you can actually manipulate the value here and then reuse this same shader over and over again with the same setup for multiple shaders that allow for full adjustment on a per case basis without having to do any recoding. So this is ideal, and it lets people tweak. Artists love to tweak, and this lets them tweak, so they'll be happy. And that's ideally what you want. Alright, and so that is a glow shader. It looks pretty cool. You should be getting glowiness, and with that, that finishes the glow shader with vertical and horizontal blur for image filtering. And now you know how to also do a blur shader, because again, just drop off your glow and now you just have a regular blur shader. So if you need to make the screen blur out, you know, maybe on the death of a character or something like that, and the whole scene needs to blur out, there you go, you have your blur shader too. But with that, that finishes this video. And my name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.